In this video, we're working on the topics of our first week. So we're going to be going over two handouts and discussing the kinds of Java variables to use in Java programs, and also introduce some new library classes that we can use with text data. So I'm going to continue using Apache NetBeans integrated development environment, and to get started I am creating a new project using NetBeans Wizard. So I'm just going to click File, New Project, and choose Java with and Standard Java Application. So clicking Next, and here I'm going to name it Week 1, and I already decided that my plan is to use location on my hard drive, which is the simple path CBCC CIS257. So I'm just going to use this location for this course. And I can create new main class. So I'll just name it main app, so that we can continue using the wizard, and it will automatically generate the package for us, which is named Week 1, and this is the file generated with the main class. So I'm just going to get rid of some of these Java docs that we can save some space, and this is our starting point. So the class is named main app, and I'm just going to mark the ending of my class, and also this is our main method. So the first presentation is called Object References Overloaded Methods, String Object Overview, and some of the library methods that are also available for printing text. So I'm just going to open this presentation. And this is just a quick reminder that we have two fundamentally distinguishable types of variables in Java. One of them are represented by primitive data types, such as integer, character, byte, double, and other types like this, and they're called primitive types or fundamental types or basic types, and they're understood by the CPU directly. So these variables, such as int count equals 100, basically represents a variable that stores the data, and of course it has some kind of arbitrary address in computer memory. But generally speaking, this address is not available to us. We access this variable by its name. The second type of variable in Java is object reference. Overall, object references store addresses of objects. So here we have string name stir equals hello. So somewhere in computer memory, there is a sequence of characters that stores characters HELLO, and it resides at a certain address in computer memory. So this address, for demonstration, this 240713, is actually what is going to be stored in object reference. So object reference provides access to the object, but we never get to work with object directly. We use a reference to access the object at a specific place in memory. So compared to primitive data types, they store values such as this integer. They store values at specific location of the variable itself. So these are basic rules for primitive types and reference types. So primitive types directly store data, and reference variables store the address of the object. Object is an instance of a class, and recall that we create objects by using operator new. Operator new instantiates an object in memory and invokes class constructor. So constructors have the same name as the class, and if no constructor exists, the Java compiler will provide a default constructor. So when default constructor creates an object, it initializes each primitive field to 0, and each object reference is initialized to a null reference. So null reference represents a reference of non-existing memory location, such as location 0, so that we deliberately place a reference in a state that indicates that object does not exist, and therefore such reference, which equals null, cannot be used to access any object. So constructors cannot have a return type. It's just a syntactical feature of constructors. To demonstrate, let's go to our package and add a new Java class. And we can name this Java class a widget like this. And one gets created. We can again get rid of Java docs. This is class widget. This is just only for demonstration. And we can start adding some data fields or data attributes. Right, and we typically would name them private. So here we can have an integer code. And also we can have private string description. So in case, if now, let's move this to a separate document group. I'll close my projects for now. And if back in the main method I would like to create this object, I can say widget equals new widget, and I'll just use the default constructor to define this object. So this is general syntax, and like we specified in our presentation, constructors do not have a return type. So if I wanted to add a constructor to this public class widget, I would typically add a comment that this is my constructors section, and here I can have a public constructor that, for instance, could take so widget, perhaps I can use a default constructor and specify its empty body. So constructors don't have a return type, not even a void return type. So it's not part of the syntax. This is not how constructors are spelled out. They do not have return type. So when the new operator is invoked by a Java program, what happens is that the memory is allocated with the space for this integer code and this string object, which is named description. Now, if I do not provide any constructors to my object, then the default constructor will initialize this code with 0 and this description with null reference. So let's verify this theory, and somewhere inside my class I can right click and say that I would like to insert some code, and I would like to insert some getter methods. This is very convenient in our IDE, and I will provide getters for both of these. I'll just say generate, and you can see that the wizard inserts get code and get description, which trivially returns the code and description. So let's print our object after creating it. We can use system.print, and we can then print our widget's code. Right, we'll say get code. We can concatenate this with some kind of space, and also concatenate this with a widget. Get description, just like this. So it's pretty simple. After doing some of the coding, if I would like to follow the default style that comes with NetBeans, I can just go to source format. So that kind of formats everything for me like this. I think I have this extra semicolon right here. So let's just verify if this format continues to be like this. So anyway, let's save it and try running it. And we will see that actually, let's insert a new line also. Right? So we can add new line like this and run again. So here it prints code 0, and the reference to our string is initialized with null reference. For the purposes of debugging, the system class, this output stream object in its print method allows to print strings and other objects that have null reference, and it simply prints null. As you can see, my output displays this null reference. So that's the point. And if I add my constructor like this, without any effort of initializing these two data fields with anything else, let's save this and run again, and the result is exactly the same. So of course here we could add some code to provide initialization to our data fields. So we'll just do it later on.